In our planned workflow scenario, we have two main actors. Our first actor is a data expert. He will use his knowledge to create a workflow or service chaining implementation that is capable of executing a data quality analysis of two or more data sets with the overlapping content merged in a conflation process. Our second actor is a non geospatial user and is not so technical savvy. He does, however, have access to various types of data sets over New York that he would like to have analyzed for data quality and merged into a more complete data set. One of the main goals of our scenario is to show how a geospatial expert can create a common workflow consisting of various types of WPS processes from totally different web processing services and share that workflow with others who may not have the expertise or the resources to use these processes individually. By combining several different processes into one workflow, the data expert helps our non geospatial expert by removing several layers of complication, making the overall goal of creating a more complete data set much easier to obtain. In scene one of our scenario, our data expert will compose a common workflow that will be stored in the catalog and discoverable by other users. He does this using CompuSolt's new WPS client. This client allows the user to select processes from various web processing services and chain them together in the desired order of operation. Once the process chain has been defined, the WPS client allows the user to generate a business process modeling notation or BPMN document and push it to the 52 North's workflow engine. The workflow engine processes the BPMN document and dynamically creates a new WPS process which is inserted into the workflows engine's own web processing service. The workflow engine then notifies the WPS client that a new process is available. To gain access to this new WPS process, the WPS client instructs the CSW catalog service for the web to reharvest the workflow WPS, thereby making the new process available to other users to be executed. Because of all the various services and data sources mentioned above are protected, various security checks also need to be done in the workflow. In other words, the user needs to be authorized in order to run the workflow before any processing can begin. Therefore, security concepts for delegating privileges, tunneling proxies, and identity mediation have also been implemented and will be discussed along the way. Scene 1, Workflow Composition. The ability to generate a BPMN document from a WPS process chain and update the 52 North's workflow WPS workflow service involves several steps. In the first step, the applicable web processing services need to be published in CompuSolt's Web Enterprise Suite CSW catalog. The second step involves using the WPS client to create the workflow. During this step, the WPS client queries the CSW catalog using optional keywords or file type credentials. Once the process list is loaded, the user can select the WPS process they would like to start with. In this case, our data expert selects the coordinate transformation algorithm from the coordinate transformation WPS service. The WPS client contacts the applicable WPS service to present the appropriate process information, which includes the process, identifier, title, abstract, and metadata links. It also includes the applicable list of inputs as well as a selectable output type. After selecting the Next button, we can see that the coordinate transformation algorithm process has been added as the first process in our chain. To select the next process, our data expert selects the Add New Process button. Selecting this button queries the CSW once again using the output type that was selected in the first process. This is done for each new process added to the chain. Next, our data expert selects the temporal consistency process, the last process added by our data expert is the hootenanny conflation process from the conflation WPS service. Now that our data expert has created the desired process chain, the next step is to generate and send a BPMN document representing the chain to the workflow engine. This starts the background process to update 52 North's workflow engine. In order to push the BPMN to 52 North's workflow engine, a security access code is required. An access request is sent to 52 North's OAuth security server. The OAuth security server responds with an access token, which will be used to talk to the workflow engine. The BPMN document is then sent to the workflow engine via an insert process request. Once received, the workflow engine processes the BPMN document, dynamically generates a new WPS process, and then adds it to the workflow WPS. The workflow engine then sends back an insert process response. If deemed successful, CompuSolt's WPS client instructs Web Enterprise Suite CSW service to reharvest the workflow WPS Scene 2. Workflow execution. In this scene, our non-geospatial expert is searching for a process that he can use that will analyze the datasets he has over New York and will merge them together in a more complete dataset. He starts by launching CompuSolt's WPS client and enters the keyword conflation. From the list of processes, he selects the conflation workflow process from 52 North's workflow engine WPS service as the process abstract seems to match what he is looking for. Our non-geospatial expert then uses the configure process screen to enter his dataset information. He has 3 datasets in different formats, 2 in zipped shaped format, and 1 in OpenStreetMap. Once the inputs have been correctly configured, he selects the output format he wants from the output type pull-down list, and in this case, he selects zipped GDB. Using Web Enterprise Suite's new portfolio data management system, our non-geospatial expert can now view the conflated dataset.
This time we have to sign in with the Auth0 instance for 52 North. We can do that with Google again. So authentication has finished. Now we can select the layer and load it. This concludes the recording.